Hello, this is Mr. Huber. In this lesson, we're going to do some analyzing of data. We'll look at some measures of central tendency, which you're relatively familiar with, and find ways that we can organize, interpret, and look at sets of values. Okay, so our measures of central tendency, so what's going on at the center of our data, are mean, median, and mode. Okay, mean, and you'll notice this little symbol here, X with the line over it, that's read as X bar. That's just a symbol that we could use for a mean or an average. Okay, so if you see that, that indicates a mean. Okay, mean is your average. So you add up, you take the sum of all the data, and you divide by how many data values you have, how many pieces of information you added together. Okay, the median, the number in the middle, you have to have your list in order from least to greatest in order to find your median. So that's one of the first things to do. If your list isn't organized in order from least to greatest, do that to help you identify the middle. And the mode is the most frequently occurring value or values. You can have more than one mode. Okay, if there are two different numbers that occur 4 times in the set of data, and nothing is occurring more than that, you have both of them as a mode. If something occurs twice, another piece of data occurs 3 times, the one that occurs 3 times is the mode. Okay, so it's the most frequently occurring, not everything that occurs more than once. All right, and you can have more than one mode. And then some other ways we can analyze data is range. That's the difference between the greatest and least values. That shows us the range of values we have, how far are we going with our data, from what's the lowest value to the highest value. And then a term outlier is a value that's very different from the rest of the data. So you've got a bunch of data that are all pretty closely related, and then 1 or maybe 2 values that are way outside of that. Those are called outliers. And those can affect the data, and we're going to talk about how that might happen and what we can do in those cases. Okay? So first let's look at mean, median, mode, some things that you're relatively familiar with. So we've got a set of data here listed. We want to find the mean, median, and mode and range for the data set. Then we're going to identify any outliers. So the first thing we're going to do, find the mean, median, mode, and range for the data set. Then we'll talk about the outliers part. So here's our data. Okay, and the first thing we should do is write these in order from least to greatest. Okay, so our smallest value is 56. Then our next is 59. And I think what can be helpful here is once we write the 56 in our list, cross it off. We've written the 59, cross it off. We have another 59, so we write that again, cross that one off. That way we know we're including everything. And it helps us focus in on now there's only 4 values left. We can see what those are. So next is 65. We go through our list, and next is 65. Then we have 73. And finally 98. Another thing you can do is count the values. So in our original list, we had 1, 2, 3, 4, 5, 6, 7 numbers. Here we have 1, 2, 3, 4, 5, 6, 7. That helps us make sure we didn't forget anything or write something more than once we didn't mean to. So you have that organized list. If your list that we just written down isn't organized properly, if you have values missing, it's going to throw everything else off. So it's really important to be careful on that first step when you're organizing your list from least to greatest, that you do it properly. Okay, so now let's talk about the mean. Okay, so the mean would be adding all of these values together, which comes out to 475, and then dividing by there are 7 values. That comes out to about 67.9. Okay, mean. The median is the number in the middle. So we want to look, there are 7 values that we counted, so I go 1, 2, 3 from this side, 1, 2, 3 from this side, so 65 is going to be my number in the middle. It can be also valuable here if you want to. You could start crossing values out, so I could say, okay, I'm going to cross out 1 from each end, another 1 from each end, another 1 from each end. I'm left there in the middle with my median is 65. So my median is going to be 65. Then the mode, that's the number that occurs most frequently. So I want to see if there are any numbers that occur more than once. 59 occurs twice, 65 occurs twice. So I have 2 modes, 59 and 65. It's called bimodal, by 2 modes. Okay? So mean, average, add up all the values, divide by how many there were. Median, what number is in the middle, and the mode, what number occurs most frequently. Okay, so we calculate our mean, median, and mode, and then our range, okay, So the range is going to be 98 minus 56, right? So our range is our highest value, 98, minus our smallest value, 56, and that comes out to 42. So our range is 42. The next piece of this question asked us to identify any outliers. So we want to see if there's any numbers that don't generally fit in with the rest of the data. We can see most of these are relatively close to one another, and then we have this 98 out there that's kind of substantially higher than the rest of where the data fits in, right? From 73 to 56 is a difference of 17. To go from 73 up to that value is 25. So from the least value up to 73 is 17, and then go to the next value is another 25. That falls quite far outside of the rest of our set of data. So our outlier here would be 98. The outlier is 98. Our outlier is 98. So our next part is, if there's an outlier, which there is, calculate the measures of central tendency without that value. So we're going to calculate mean, median, and mode without the value 98 in there. So I'm going to rewrite my list down: 56, 59, 59, 65, 65, and 73. Okay, didn't include the 98. And now I'm going to calculate mean, median, and mode again. So to calculate my mean, I'm going to add all these values together. It comes out to 377, and now I'm going to divide by 6. So there are 6 numbers in my list now. And so that comes out to about 62.8. Okay. My median is the value in the middle. Well, this is a little different than we saw last time, because if I want to look at my middle value here, if I cross off from each end, I come down to where I have now 2 values in the middle. So in order to calculate this, I calculate the average of those 2 values. So my median is going to be 59 plus 65 over 2. 59 plus 65 over 2, and that comes out to 62. So when you have 2 values in the middle, which will happen anytime you have an even number of data points. So here we had 6 pieces of data. That's an even number. Our middle is going to be 2 values that we're going to have to average. Okay? And then our mode, okay, the mode is still 59 and 65. Those are still the 2 values that occur most frequently. Those are our measures of central tendency. Okay, mean, median, and mode. We don't have to calculate range, I just said find the measures of central tendency. This is kind of happening at the center, right? The mean, median, and mode are telling us what's going on around the center of our data. And one thing you should notice from this is that the value that's affected most by an outlier is the average. Right? The average is most affected. This total here, 475, was affected a lot by the 98. So it brought the mean up quite a bit. Okay? The median changes a little. Okay, that's fine. Not too much. And the mode didn't change at all. But the mean is going to be the measure that's affected the greatest by an outlier. So keep that in mind. Okay, if you have an outlier or 2, it's going to affect the mean the most, either bringing it up or down if that outlier is on the top end or bottom end of our set of data. All right? So mean, median, and mode, measures of central tendency, range, and understand what an outlier is and how it can affect the data we work with. A little golden moment here, the significance of the Olympic symbol. We see it here. You see it on the flag that flies at the Olympics, other different things symbolizing the Olympics, winter and summer games. It's 5 interlocking rings, those each different colored. Okay, it's known as the Olympic rings, and it's significant because it was selected for very specific reasons. Okay, the symbol was designed in about 1912, all right, by the person who was the co-founder of the Olympic Games, okay, Baron Pierre de Coubertin, and he selected 5 rings to indicate the 5 continents. You might be thinking, there's more than 5 continents. Well, the 5 continents identified that he was going for were Europe, Asia, Africa, Oceania, and the Americas. He kind of combined North and South America, and then Antarctica isn't a competitor in the Olympics, so he wasn't really considering them. So the 5 interlocking rings showing that they're together, they're bringing everyone together, and the 5 colors that were picked were because those 5 colors and the white background of the flag include colors of every country's flag that was in the first Olympics. So it covers the color scheme of any country's flag is somewhere in that ring, and their continent is included in there as well. And it was first officially debuted at the games of the 7th Olympiad in 1920, and it's been used ever since then. So those 5 Olympic rings, okay, the 5 rings indicating 5 continents that compete, coming together, interlocking, and then the colors there that include colors of any national flag. All right, let's look at something else we can do with our sets of data. We know that a median divides the data into 2 halves, right? It's the number right in the middle. Okay? Each half also has a median. That divides data into quartiles. Think, if you take something and divide it in half, okay, let's just draw anything out here. So if I take some rectangle here, and I divide it in half with a median, then I divide each half in half. So this would be Q1 and Q3. I think first quarter, third quarter. So I divide each half. Now I've got quartiles. Okay, I've got 1, 2, 3, 4 sections. So I divide it in half, and I divide each half in half. This is 1 quarter of it, 2 quarters, 3 quarters, 4 quarters. This is Q1. The median would be Q2, Q3, and then Q4 would be at the end. Okay, but Q1 and Q3 are quartiles. Okay, or divide these data into quartiles. And then there's a range of Q1 and Q3. It's called the interquartile range. In many instances, it's a better measure of what's going on with the data than the full range is, because we saw where the range can be affected by an outlier. Okay, so Q1 and Q3 really do a better job of telling us what's going on with the middle 50% of our data, right? This is half of the data is between Q1 and Q3. So it really tells us a lot about what's going on in the middle of that data. It can tell us how spread out the middle is, how compact it is, how much it might be towards one side or the other. So Q1 and Q3 are important, and the interquartile range between them is important. So we're going to see where we can use those with some information coming up here. Okay, so there's some data here in this next problem that gives the temperatures, okay, for the water off the coast of Key West, Florida, in each month. So January, February, March, April, May, through on till December. Okay. We're being asked to find the interquartile range. So in order to do that, we need to know the median. We need to have this data arranged in order from least to greatest. So let's start with that. All right. So the first thing I'm going to do is rewrite this data set in order from least to greatest. So I'm going to have 68. Again, it can be useful as you're doing this to cross them out as you use them to make sure that you're including all the values you need to, that you're not missing anything or doubling up, writing something down that you couldn't remember if you wrote down or not. Write down all the values. If there are ones repeated, you write them as many times as they appear in your original list. And then I could count again and make sure I've got 12 numbers there. And that I started with 12, because one for each month. Okay. And so first I want to figure out the median. Okay. The median would be in the middle here. Okay, I've got 6 values above where I just drew that kind of red little arrow. So my median here, I've got 12 points of data, right? If I've got a middle here of an even number of data points, then I'm going to have to average the 78 plus 82 and divide by 2. So my median is going to be 80. Okay, that's the median, 80. Q1 is the middle of each half. So we're going to take this first half of the set of data. Okay, this first half of the set of data. I have 6 numbers here. And I want to find the middle of those 6. So the middle of those 6 is going to be right in here. 3 below it, 3 above it, the median right in there of that half of the data. So this is going to be Q1. I add together the 72 and 75, divide by 2, I get 73.5. Okay. Q3 is the half of the other half of the data. half of the half, right, cutting it into quarters. Q3 is average of 85 and 86, which is 85.5. So I have Q1, 73.5, Q3, 85.5. So to find the interquartile range, okay, interquartile range, I'm going to find the range between those two quarters. So it's going to be 85.5 minus 73.5. My interquartile range is going to be 12. Right? So again, this describes the middle of the data very well, our quartiles. What's going on here in the middle. Okay, it wouldn't be affected. There's not really any outliers in this, but if there are, we saw where that could affect things. Okay, so our interquartile range, we find Q1 and Q3, which are the middle of each half of the set of data. Right, median in the middle, then middle of the first half, middle of the second half. Now another thing we can do with this and a way to display data is to draw a box and whisker plot. There's an example of it here. I'm going to walk through it and then we're going to draw one out for that data that we just had. Okay. So a box and whisker plot looks like a box there in the middle, and then these kind of branches off to the side are the whiskers. Right? We have a box and then we have a whisker and a whisker. We're going to set up kind of like a number line below it. This is going to be values on it, right? There's going to be actual numbers when we write it out. And when you draw it, the 5 key pieces of your box and whisker plot are your minimum and maximum values from your data set. This box goes from Q1 to Q3, and you draw a line through it where the median is. It's not always going to be in the middle. Again, depending on where Q1 and Q3 are, the median might be a little closer to one side or the other. These whiskers aren't always going to be the same length, depending on how far out from each Q1 and Q3 you go to get the minimum and maximum. And you can see here, our interquartile range, right, is Q3 minus Q1. It's the range of that box part of our box and whiskers. So for the data that we just drew out, I'm going to count by twos, right? That's an important thing to figure out. What am I going to start my number line with? Where am I going to end? What am I going to count by? I'm going to count this by twos, okay? And so I'm going to draw out kind of a number line. And I'm going to start at 66. 68 is my smallest value, so I'm going to go by 2. 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, and I don't have to go above that. My highest value is 87. So I would be able to contain my whole box and whiskers here. I could have probably even spread that out a little more, but I can draw a box and whiskers now. So 5 key points. First one will be the minimum. The smallest number I had in my list of data that we just used. Again, we're going back, we're using this same data here. So we've got our smallest value is 68, our highest value is 87. Okay? So our minimum is 68. Our maximum is 87. This is 88, and this is 86, so 87 right there. It's going to be my other end point. I like to put points there. I know on theirs they have a little line on the end. I like to put a little point there. It makes it a little different than the box part. Okay, so that's my minimum and maximum. That's my minimum value. This is my maximum value, 68 and 87. Okay. Then I'm going to draw my box. Okay. So for the box, I need to know what Q1 and Q2 are. Right? Q1 was 73.5. Q3 was 85.5. So 73.5 is going to be right around here. Just saying, get to my pen there. It wasn't working. So right there. Right? This is 72. This is 74. 73.5. Just a little less than 74. So I'm going to mark that here in for my box. Right? I'm going to draw a line straight up and down there at 73.5. Okay. Then I'm going to go to 85.5. So that's just about to 86 here. So 85.5. So I'm going to put that there. That's going to be 85.5 right there. 85.5. That's my Q3. I can draw a box then. That's my box part. I could draw the whiskers now in too if I want. There's my whiskers there and there. Again, you can see one's longer than the other. That's fine. And then my median's the last thing to put in there. My median's at 80. So I'm going to draw a line down at 80. That's my median. Again, this is Q1. This is Q3. And this is my median, or Q2. Right? So get box and whiskers. The whiskers from the minimum right here, the maximum out here. Then my box goes between Q1 and Q3. Put a line down where the median is. It doesn't necessarily have to be right in the middle. Okay? And I've got my box and whiskers plot. And this can be a way to visualize and see, like, kind of this maximum isn't too much higher than Q1, or Q3, excuse me, right? There's a longer distance here to get down to Q1. We can see kind of how big our middle is, right? The 50% here in the middle from Q1 to Q3 is the median, closer to one side or the other. So you can visually see from that the same kind of thing you would up here with a list of numbers, but sometimes it's a little better to see it visually on that box and whiskers, all right, than trying to picture all those numbers and what they might look like. So know the key features of a box and whisker plot, 5 key features, and how to draw one.